Hello class, welcome to Unit 7.4 Factoring GCFs. Okay, so in Unit 7.4, when we start talking about factoring using the greatest common factor, first of all, we need to remember that factoring is essentially breaking up your polynomials into simpler terms. And this is really just like the process of dividing. If you think back to when we broke up numbers and factored like 24, we could do like factors of like 4 and 6. You could take 24 and do like 2 and 12, and the list goes on. So when we're looking at factoring, we're just essentially trying to find two numbers that will multiply to get back to that number. But now that we're talking about polynomials, it's going to be a little bit more than that. So when we talk about the word greatest common factor, this is going to be the largest number or the largest term that can divide evenly into two or more other numbers. So again, kind of like we talked about up here, if we were looking at 24, but now we're looking at two different numbers, you'd have to be looking at like something like a 24 and a 16. And we need to kind of just go through all those factors and kind of look and say, well, I could divide that by 8 and I could divide that by 8. And there's really no other number that's bigger. So your greatest common factor would be an 8. When we're talking about new with polynomials, now there's going to be an exponent portion. So first of all, the variable that is in every term, and we need to take the lowest exponent. So we need to make sure it's in every term, and then we're taking the lowest one. So what we're going to start seeing things is like x squared y, and we might see like x cubed y to the third. And what we're really looking at doing is trying to say, okay, in x's, take the lower one. In y's, we're taking the lower one. So our greatest common factor of those two would be like an x squared y1. And we'll kind of look more at that as we go. But it's going to always be the smaller of those exponents. All right, and just a couple things to kind of remember. The first thing we're going to be looking for is look for the common numbers. So we're looking for the GCF of the numbers. Secondly, we're going to be looking for the GCF with your variables, which was that lower of the two. Third, we're going to start talking about division. When we divide, we want to remember that is when we subtract exponents. And then finally, with these, your answers should look like a multiplication problem. Whether we're going to break it into something that looks like a distributive property or something that looks back to like a binomial times a binomial, that's what our answers should look like. So let's take a minute. Let's take a look at some examples here. Okay, so let's look at example 1. If we're trying to find the greatest common factor of a 4x squared plus 2x, remember, we're looking for the biggest number that 4 and 2 can be both divided by. So 4 and 2, usually look at the smaller number. And as long as the first number is divisible, the 4 is divisible by 2, that's going to be our greatest common factor for our number. And if we look at x squared and x, we're always going to take the smaller of the two. Just because x can divide by x, that means anything bigger than that can also be divided by x. So once you determine what that GCF is, now we're looking at, well, 4 divided by 2 for this first one is going to be 2. And if we have x squared and we divide that by 1, remember, dividing is subtracting, so we're left with x. When we look at 2 divided by 2, that's going to be plus 1. And an x divided by x would also be plus 1. So when you're dividing something by itself, remember that always equals 1. And that would be your factored answer. Now keep in mind that we are trying to basically undo the distributive property. So if we take a second to try to distribute back into this, we should return to that final answer. So 2x times 2x is 4x squared. 2x times 1 is 2x. So basically, when you're factoring out, if you can distribute something, we can factor it out. So let's take a look at example 2. If we look at our 5 and 3 first, well, they do not have any common factors with your number. But if we look at our x squared and our x, again, we are looking to take that smaller of the two out. And that way, when you look at this and we say, okay, well, we can't divide by 5. But if we have x cubed, if we take 2 out, we're left with 1. Again, with the minus 3, can't do anything. And then x squared divided by x squared is just going to be basically 0, which we said is a 1. So right there is our GCF. We're taking the biggest thing we can divide by and the biggest, the smaller of the two exponents, because that's going to be divisible. And again, you can always double check your work by distributing. And x times x squared becomes x cubed. And then a negative 3 times x squared takes you right back to your answers. All right, one more to look at. So if we look over 3, same thing applies if we are looking at multiple variables, but you treat each one separately. So look at 4 and 12. 4 is the smaller of the two numbers, so can you divide 12 by 4? In this situation, we can. When we look at x squared and x to the 4th, we can divide both of them by x squared. Y and y 4th, we can divide by y. And then it's just a matter of taking each one. Take that first one, 4 divided by 4, that's 1. X squared divided by x squared, that's 1. Y and y, also 1. So this case here, when we divide out, we're dividing everything. When we go to the next one, well, what's 12 divided by 4? So that would be negative 3. X to the 4th divided by x squared. Again, we're just subtracting the exponents. Y to the 4th divided by y. So that would be y cubed. And just remember, okay, this should be our answer here. But we should be able to distribute back in. 1 times anything is itself. And then when we distribute here, 4 times negative 3, that's negative 12. X squared times x squared, add your exponents. And y times y cubed, y to the 4th. And there we are, back to our original. Okay, take a look at a couple more. Okay, so nothing's going to change about how we do them with 3. The only thing different now is just looking at 7, 14, and 49, and we need to make sure we find a number that's divisible by all of them, which always start with your smallest number, 7. And it looks like 7 is divisible, 14 is divisible by 7, 49 you can divide 7. And if we look at our x's, we're always looking for the smallest exponent. And then what we're looking at is, well, 7 divided by 7 is 1. X to the 5th divided by x, that is subtract 1 from each of these variables. 14 divided by 7 is 2. X cubed minus 1 becomes x squared. And then negative 49 divided by 7 is a negative 7. X divided by x is just 1. So there we are with our answer. Once again, we can just take a quick minute to kind of redistribute, double check our work, and yes, that would take us back to our answer. Okay, looking at our next one, same deal, 8, 4, and 2. Always look at your smallest number first and say, all right, everything divisible by 2. In this case, yes, it is. So we know we're going to be able to factor out a 2. Look at your smallest exponent, 2w, and then we kind of work our way through. 8 divided by 2 is 4. Taking away 1 from 3 is 2. Negative 4 divided by 2 is 2. And we're taking away 1. And then 2 divided by 2 is 1. W divided by w is 1. So that would become a plus 1. And again, after you get done these, just kind of double check that if we multiply, yep, that gives us 8w cubed. Yep, that gives us negative 4w squared. And anything times 1 becomes itself. So we are in good shape there. All right, last one to kind of look at here. Once again, we're just looking at our numbers. 150 and 25. Is everything divisible by 25? Yep, everything is good here. Not everything has an x, so we can't divide by an x in this one. So what's 100 divided by 25? And since we're not, factoring out any x's, that stays x squared. 50 divided by 25 is -2. And again, we're not taking out any x's, and anything divided by itself is going to be a +1. And again, we should be able to just kind of check by distributing and confirm that we are good. All right, go ahead and practice these next couple. So pause here, practice before we check our answers. Okay, double check your work. Make sure we are factoring out, first of all, factoring out the right factor, and make sure when we are dividing and kind of factoring them out, we're good to go. All right, good luck. Have a nice day.